All right, how you guys doing today? So we just finished up a unit on factoring quadratics. Hopefully you guys submitted those quizzes to me. It looked like from the ones I've gotten so far that you guys have been doing a really good job on that, which is good to see because it's going to help you out a lot with this next unit that we're doing. If you haven't watched all the videos from the last unit, please go back and do that before you start on this unit, because this unit is going to be very difficult to do without doing that first unit first. So what we're going to be doing today, which I know is going to sound like a lot, is finding the roots, zeros, and x-intercepts of quadratic functions. Now this sounds like we're going to be finding a lot of things, but in reality, all of these things actually mean the same thing. The roots, zeros, and x-intercepts of a quadratic are all referring to exactly the same thing. So I just wanted to sort of show you that somebody could ask you to find the roots and somebody could be asking you to find the zeros, and in both cases you're going to be finding the same thing. Now, what we're talking about with that is, if you remember from our graphing unit, we graphed some quadratic functions. So you might see a quadratic function that looks something like this, or you might have seen some, especially some of our more realistic ones, where you saw something that looks like this. Now, when we had that, we found what was called our vertex. Those were our maximum and minimum points. What we're going to be talking about today is how we can find the roots, zeros, and x-intercepts, and that's referring to these points right here where they cross the x-axis. This is when y is equal to 0, so that's why sometimes it's called our zeros. Other times it's called our roots. If you remember from when we were graphing quadratics, there were a couple questions where they asked you when is something going to hit the ground. That essentially is asking you to find a root of that quadratic function. So I'm going to give you two quick examples today of how to do them, and we'll see how it goes. So first example I'm going to give you is if we have a function, if we have something like f of x or y is equal to x squared plus 6x plus 8. Now, if you went to graph that in your calculator, I don't want to take your time up right now and do that, but if we went to graph that in our calculator, I think you would get some sort of a function that looks something like this. And what I want to find today is these 2 points right here. Our x-intercepts are zeros, or sometimes they're referred to as the roots. Now those occur when this function right here is equal to 0. When our y equals 0. When y equals 0, that's where they're going to cross. Now you're going to see from our graph that we should actually end up with two different spots as to where they cross. They're going to cross here and here. Now we don't know exactly where they are right now. That's what we're going to find today. So here's our function, x squared plus 6x plus 8, and I want to see when that equals 0. Now the way we're going to solve this is the same way that we were doing in the last unit when we were doing factoring. So we're going to factor this x squared plus 6x plus 8. So that's where I look to see if we have a GCF, a difference of perfect squares, or a trinomial. In this case, I have a trinomial, so I'm going to do that x method. I'm going to put my 8 on top and my 6 on the bottom, and I'm looking for two numbers that multiply to 8 and at the same time add to 6. In this case, we're talking about 4 and 2. So essentially, I can rewrite x squared plus 6x plus 8 as x plus 4 times x plus 2 is equal to 0. Now, once we factor like this, it's going to make it a lot easier for us to find those roots. because now basically what I'm saying is x plus 4 has to equal 0, and x plus 2 has to equal 0. So I can very easily solve these two separate equations here, minus 4, and I get that x equals negative 4. Here I'm going to subtract 2, and I get x equals negative 2. So this tells me that the two spots that these cross are at negative 2 and negative 4. Those are the roots of this function. I know it's a little tricky. This is our first example. So I'm going to do one more here, and then we'll probably spend a lot of the next lesson just doing a lot of examples of these to hopefully help us out here. So let's check out one more example here. This is our function of, we'll do f of x equals x squared minus 2x plus 35. Now, if we went to graph this in our calculator, I'm not sure exactly what it's going to look like, but it's going to look something like this. And again, what I'm trying to find out is these two spots right here. We're going to be finding our roots. So to find our roots, what we do is we set this function equal to 0. So we're going to say, when does x squared minus 2x plus 35 equal 0? So again, we're going to try and factor this just like we did all last unit. That's why we spent that whole last unit on factoring. In this case, again, I have a trinomial, so I'm going to use that x method. I'm going to put a 35 on the top and a negative 2 at the bottom. I'm looking for two numbers that multiply to 35, but add to negative 2. Let's actually make this a negative 35 so that it actually makes a little bit more sense and works out for us. Sorry about that. So in this case, we'll say this is negative 7 and positive 5. So when I factor this, I'm going to have x minus 7, x plus 5 equals 0. And now I'm going to set each of these factors equal to 0. So x minus 7 equals 0, x plus 5 equals 0. So my two answers here are going to be x equals positive 7 and x equals negative 5. Now, once you do a few of these, you're going to be able to go just from here and say, okay, my roots are going to be 7 and negative 5. But I want to make sure I'm showing you where this is coming from, since this is just our second example. All right, I know this is probably a lot to throw at you in one short lesson here, so we will definitely come back to this, and we'll spend a lot of time doing different things with this, but just wanted to give you a basic introduction here today. Hopefully you kind of got the gist of it. I'll give you a few examples to try, and we'll see how it goes.